All right, I'm going to start out talking about assignment 2, which has not shown up yet. That's not cute. It will show up soon. Oh. Dumb. It ignored all my dates. Okay, there's part 1. Part 1's a slight review on database design. Not design, but diagramming. By now you've played with database design enough, and you've looked at databases and diagrams enough, you should know what to do with this. And you've had your feedback from assignment 1, which should help you with this. It's a very simple diagram. It's given to you. It's very broken. Fix it. It's a practical application of all the theory you've learned. There's so many things wrong with this diagram, it's unbelievable. Huh? Yeah, fantastic. So, what else am I supposed to say? You feel sick, I feel sick too, because actually, believe it or not, this is a diagram a student handed me once. Literally, I shit you not. This was one of my old assignments, which was a diagram for me a mailing campaign database. Minimum 3 entities. That is what was handed to me. Not, suffice it to say, concerning the assignment, it was out of, at that point, that part of the assignment was out of 10, he got 0. He lost everything for the naming conventions. And whatever, and nothing was actually designed properly, nothing was connected, no relationships, it was automatic 0. And this one here, I'm kind because I made it out of 11. Like, you get a free point if you name your file right. Because I always do this with assignment 1, I say, okay, here's what your files should be called. And then everybody hands it in and nobody followed the naming conventions for the files. Now I give you a free point. Name your file right, you get a free point. Essentially, you do not need more than 3 tables for this. So don't worry about breaking it down to a million pieces. I just want you to fix what's there. What is this? How many of you receive email campaign messages on a regular basis? All of us, right? How many did I get today? Like 10? Apparently I got at least 3 from Spotify. And what these things are is there's a list of contacts, there's a list of campaigns, and then there's a table that describes what contact received what campaign and where. That's the only hints I'm giving you on what this database structure does. It's up to you to try to figure out the rest. Okay, part 2 of assignment 2. This is to test your SQL skills. This is very similar to the practical test, except the big difference is everybody gets the same questions. It's not randomized. It's not in a random order. You all get the same test. This works with the ThinkCube database. As you can see, I provided a link to it in case you end up wiping your laptop sometime in the next 2 weeks and you go, oh no, where do I get the ThinkCube database? I don't know, Lab 1? If you can't remember that, I provided a link so you can suck it down. What can you expect in assignment 2, part 2? 13 questions. You type in, it asks you a question. You write the appropriate SQL statement to answer the question. You make sure you understand your SQL statement. Then you type in the magic number or the word or the name or whatever the question's asking you for, and you hit save. Now, the first question I always get at this point is, do I get to submit it more than once? What do you think the answer is? No. Why do you not get to submit it more than once? Do you get to submit your midterms more than once? You go to your Java class, and Howard, or whoever it is that teaches you your Java class, Howard teaches you that, and he gives you your midterm. You sit down, you write your midterm, you hand it back to him. Do you get to say after you've gone down the hall, shit, I should have done this, and you ask him for your test back? No. Same thing here. You write your test, you do it, you save, you accept the results of your ability or inability as applicable. Yeah, okay. I'm trying, look, this is the face of me trying to care. And I'm not succeeding well at all. Just putting it out there. But yeah. That's the situation with the assignment. So that's the assignment coming down the pipe. You've got 2 weeks to do this. I've seen people do this assignment while I'm lecturing. On average, normally, by the end of this class, there'll be 2 people that finished it. Whether they got a good grade, I don't know, but on average, there'll be 2 people out of a group of 100 students that'll finish it. And then there'll be about 10 that don't even bother to try it at all until 5 minutes before it's due. Don't do that. It takes more than 10 minutes. It would take me about 15 to do it. No, and I know the structure. Because I don't remember the question, so I actually have to take the time to read the question. That's why it's going to take me 15 minutes. I got to read the question and try to remember what I was asking. Which is the same thing as you reading the question and trying to understand what I'm asking you to do. Now, here comes the caveats. I honestly don't care if you try to help each other with it, within reason. That doesn't mean everybody just waits for Kevin to finish it and then copy his answers. Just using Kevin as an example. Don't do that. I find any of my questions on Stack Overflow, you will be reported for cheating, reporting you also for distributing test material to a public forum, and for making test material available to other students that are not part of a course. If you don't know what the side effects of that is, last student that did that to me got suspended for a year. Because you get 3 strikes. How many offenses did I just name? 1, 2, 3. Right, so don't post my questions to Stack Overflow or to DB Exchange or Expert Exchange. If you think I don't spend, I don't have a set of custom queries set up to run in my browser to go search for these words, you're sadly mistaken. And how do I know about this particular thing? Because I've had a student do it to me. Thus, he got the 1-year suspension. And by the way, that means you're not even allowed to set foot on the college. That means you're not allowed to go write your exams for other courses. So it's an automatic fail for your whole term. Just so you know. I've been teaching for 10 years. I've had to do it once. Just warning you now. I've only ever had to do it once. So that's a good start. But yeah, just if you're going to try to cheat, at least try to do it with half a brain. Don't use your face as your avatar. That's how I knew who it was. Dude used his face and used his real name as his username. So, you know. He wasn't the sharpest tool to start with, and that just proved it. Don't do dumb. Just don't cheat. I mean, it's not that hard, really. Okie dokie. Now to finish the lecture. Considering I already started in aggregates with you guys, this should go fairly reasonably well today. Hoping to be done by 5:20. Knock on wood. Normally I do the assignment information at the end, but this time I decided to do it at the beginning. If anybody decides they just want to run away, they can. I won't feel offended. Moonbeam, you had your hand up in the air. Oh, you were just doing a flailing. Okay. Trying to catch invisible balls. Okay. Now, last week I spoke about aggregates, and I spoke about how you can't aggregate an aggregate. And I also started talking about joins. So I've got a series of topics I got to cover, and I'm not going to go back to aggregates right off the bat. I'm going to finish talking about joins first. And joins are an interesting concept because they can be, what's the word I'm looking for? Challenging in their own way. And I was actually looking for something specific, and I can't find it. Oh no, I just failed my test. Okay, under course documents is this nice little chart. And this chart explains how joins behave with colors instead of, what's the word I'm looking for? Instead of using Venn diagrams, which is a really terrible way of explaining how joins work. There is a chart and it uses colors. Why do colors work? Because the human brain understands color better than they understand what letters and numbers. So basically put, what I've taught you guys so far is about the inner join. And just so you know, an inner join, the word inner is optional when you use an inner, you do an inner join. Because if you don't include the word inner, the SQL parser assumes automatically that you're doing an inner join. And what does it match? Things that are equal in both tables. I'm going to show you guys about the left join and the right join in a minute. And then I'm going to also show you about the full join. Well, I'm going to discuss the full join, which is basically gives you everything with nulls and applicable slots. It's not the most useful query in the world. There's one more in here that's not mentioned, and that's the natural join. I've had actually a student ask me, well, what about natural joins? What does a natural join do? A natural join, you'd go select star from customers, join orders, and that's it. No precision specification of what it is you're joining. What that natural join does, it looks for columns that have the same name. Then it connects it across columns that have the same name. Now, if all our primary keys are called ID, what column is it going to use to join? It's going to join across all the primary keys. It's going to ignore the foreign keys. It's going to use the primary keys instead. Not particularly useful depending on how your database is designed. This is legacy from back in the day where people would call their table customer, and the primary key be called customer ID, and then the foreign key in order, notice I didn't say orders, in order would be customer ID. So you're perpetuating customer ID in all the tables, and then somebody came up with a way of saying, man, our SQL guys are really lazy. They can't take the extra second and a half to finish typing this in. So we'll go select star from customers, join order. Go. And then it automatically guesses. Some of you may not realize how much I hate the concept of automatic guessing. It's a terrible thing to do. I always use the example of sending your friend to the fridge to go get you a beer, and there's 4 kinds of beer in the fridge. There's a microbrew. There's an apricot beer. There's a Sleeman's, and then a Molson 50. He brings you the Molson 50. Just, you know, because he didn't specify what it is you wanted, he grabbed the first one he saw. It's not the best way of doing things. So be explicit with your SQL, because the database servers are pretty clever. As far as computer environments go, database servers are pretty smart in their own, you know, idiot savant kind of way. But they're still like 2-year-olds. If you don't tell them explicitly what to do, they won't do it. All right, so I'm going to do a quick refresher on okay, so what I just did is I connected products to product versions. This is the same thing as an inner join, so I could have put the word inner right here, and it would have worked. By the way, for those of you that are wondering how come my keywords are all going uppercase, there's actually a setting somewhere in the settings for a pgadmin that does that. It's buried away, and if you turn it on, it does all your keywords uppercase for you automatically. Except, you know, if you use the word name, because names is also reserved keyword, so it makes your word name uppercase all the time. But, you know, such is life. So, select star from products, inner join this. This is something you've seen. It's just a straight up normal join. It's connecting on points of commonality, which in this case, the products have a primary key called ID, and the product versions have a foreign key called product ID. This is the ID of a product, and we find it in the products table. Ta-da. That's what it does. And since we're grabbing, so this basically got an ANZAP, and it's active, ID 15. You can see over here in the product version that the product ID is 15, so 15, 15, 26, 26, 10, 10. It does the match. So the next one we have is a left join. I'm going to say, give me everything. And at this, I'm going to change the formatting just a little bit for a second so that it's a little more obvious what it's doing syntax-wise. All right, select everything from products, left join, product versions. When you do left join, now if I go back to the picture, this is on the left, this is on the right. When you do a left join, it grabs everything from what's on the left of the word join and anything that matches on the right. If it doesn't return anything, it gives you a null. So if there's no matches, it returns a null. So if I do this, I go run, you'll see, I'm pointing at this screen like you can see it. You can see that everything looks like it was the same, but look down here, the number, 108 rows. If I were to take the left off and run it again, we have 100 rows. 108 rows. If I scroll right to the bottom, you'll see the magic 8 rows. So we have the products here, and then nulls across the board everywhere else over here where it didn't find matches. And people will say, well then, what good is that for me? Well, it's a good way to find products, for example, that didn't sell recently. If you could use a query that filters down, how many times was this product sold in the last month? And you have products that are not showing up in that list, or they're showing up with nulls. That means those are products that didn't sell in the last month or the last 6 months. Maybe those are products that you don't need to carry anymore because, it's just crap. That's what you use left and right joins for, is you use it to find where things aren't carrying across, not being used. You also use it to find orphans, so you can kill them and get rid of the orphans. What? Everybody hates orphans. At least in a database, we all hate orphans. Real life orphans are cute. In the database, orphans are terrible. It corrupts your data. It's a bad thing. I always use that line because everybody always remembers. Orphans in the database are bad. Therefore, we kill them and get rid of them. But that means you want to delete them. Postgres, luckily, because its referential integrity rules are so strong, you rarely end up with orphans. You have to wipe out the parents to get rid of the kids. So, you do an entire family tree in one go, which kind of sucks. But in other database servers, you might end up with bad data, and you use left joins to figure it out. Now, let's say I want to find all the products that don't have a product version. This means these are products that have never had a version defined, that have never been given a price, etc., etc. And you do it by going like this. And you pick any of these columns. Doesn't make a difference which one in here you grab. You can grab any of these. So I'm going to use product versions.id. So I'm going to grab the primary key of product versions is null. And now we end up with 8 rows. Why does that work? It works because there's a product version ID for all the ones that are defined. Therefore, the ones that aren't defined, that's how you do it. And that's how you find records that aren't being used properly or aren't being carried across. I ran queries like this recently to find out if a certain sales rep was logging into our CRM and he hadn't logged in 6 months. Don't know what he was doing, but he never logged into the CRM for 6 months. And the sessions do expire after 4 hours, so it's not like he said, I just kept logging in every 2 hours, because that's not how it works. So, that's how you find records using a left and a right join. Now, what it does, it says anything to the left of the word join. So, left join is on this side, means give me everything from products, and any matches from here. If you don't have any matches, give me a blank. If you do a right join, it just flips it around. It'll do everything from product versions that aren't in products. But since there's no orphans, you won't have this problem. You okay, dude? Okay. Now, that's a left and a right join. It's in the labs. It's the only place you're going to use it in this course. How often would you use a left and a right join in industry? Occasionally. It's not something you use on a regular basis. It's for specific targeted queries. Now, this leads me into the next topic. Now that I've talked about left and right joins, it leads me to the topic of subqueries. Subqueries are cool. When I came out of college, I thought subqueries was the shit. Honestly. I went around, and it was like using a sledgehammer to put in drywall screws. Yeah, it gets the job done. But really, you should be using the right tool for the job. Now, subqueries are cool in their own way. They have 3 separate uses. And you can use a subquery pretty much anywhere inside an SQL statement. Okay, this is a sample of a subquery. Very simple example. As you notice, I have 2 SQL statements in one command. One's included inside of brackets. Essentially the way it works is, do you remember in math by now, you should, your math skills should be not recovering from atrophy from the strike. And you should remember how brackets work. You know when you got a mathematical equation that has multiple sets of brackets inside of it? Do you remember how to resolve the brackets? Anybody? Yes, you work for your, good job. You work from the inside out. So you resolve all the inner brackets first, then it goes out and out and out until there's no brackets left. And what happens here is my subquery is inside of a set of brackets. The parser parses. So what it's going to do is actually going to run this statement. What does it do? It returns a list. A list of values. Now, if you guys remember 3 weeks ago when I talked about the in statement, which means search inside this list. In this list. So if this gives me a list, and I go, give me everything product versions where the product ID is in, it resolves this first, turns it into a list, and then the rest of the query operates on that list. What good is this? Usually people will ask. Well, for starters, I'm not getting any of the product information with it. I'm just getting the product versions here. This is the proverbial sledgehammer, because you could do this with a join just as well. And usually the join's a hair quicker. But every once in a while you end up with this weird situation where you can't use a join because the criteria is kind of odd on how they'd connect. You're dealing with really old data where, and they used to do this a lot. They called it coded IDs. Zero one would be the department. The next set of digits could be something like, I don't know, the division. And then the last digit could be the employee inside that division. And whenever you entered an employee record, you'd put in 001-00-56. But then you needed to run a query to extract the fact that, oh, they're coming from this division and that department. And all these guys have is 01, 000, and 56. They're not a single one of them actually add up to the right structure. So you'd write a fancy query that would actually concatenate the different values from the different departments, and then do that. So you'd use subqueries for stuff like that. It was pretty horrifying. Thankfully, nobody should ever do that anymore. And I'm not saying I'm not guilty of doing it, because I've done it. Because that's how I was taught, that it was a cool thing. And then I realized after my second job that it was a terrible thing. So that's one way of using a subquery. You use it to set up a set of values. So you use it to create a list. Some people will try to do this. And I can guarantee this won't work. More than one row returned by a subquery that was used as an expression. Because what does equal test? It tests against a single value. How many values does this return? 58 values. Therefore, can you test one single value against 58 values? No. Therefore, most often in here you'll use in. Or you could also use not in. So you want to exclude a subset of values. So this is one of the examples where a join would not work because you want to exclude a set of values. Therefore, you'd use not in. Give me everything in product versions that's not in this. And by the way, this is how you do an except in MySQL. Because MySQL doesn't have except. It doesn't have intersect. How do you do an intersect? That's how you do an intersect in MySQL. It's terrible. So that's a subquery. There's a few different... It does similar to join and not join. It just has its own applicable use. And there's the odd, when you need it, you'll know it. It's like one of those things where you'll try to write something and you cannot get it to work as a join. That's when you break up the subquery. And what it does is it runs this, which builds a list. And then it goes, select star from product version where product ID is in this list. Basically, this becomes and I'm going to do the abbreviated version. It takes this and turns it into something like that. Well, of course, this will only give me the first 6 because I only did the first 6 product IDs. It returns 14 rows, but this is the first 6 product IDs, 1 through 6. This returns all of them, so it'll give me all the rows. Does that answer the behavior? Well, what it doesn't actually know that. What it knows is that you've fed it a list of items. 1, 2, 3, 4, 5. It doesn't know what 1, 2, 3, 4, 5 is. It just knows that you're giving it, give me anything where the product ID is in 1, 2, 3, or 4, or 5. And so what it does is it resolves this first, and it basically turns it into a common delimited list in memory. So it runs one query, takes the results, turns it into a list of values, and then operates against it. Okay? So this is the first type of subquery. This is the easier one to understand. The next one is almost useless, but I've seen it used when you're initially loading data. So for example, let's just say I was going to create a new user, right? But I'm just going to use a select statement instead. Remember I was talking about how it's going to uppercase the word name? Excuse me, I got something in my eye. Oh. Literally felt something fall from the ceiling, which scares me. And this will give me an ID of 5. Now, some of you might be wondering, well, why would you do that? Sometimes you don't know what the magic number is. In your programming class, do you guys have Howard? Did Howard talk about magic numbers and how horrible magic numbers are? Magic numbers are terrible things. It's, you go, if condition equals 1, then do this. What the hell is 1? You know what 1 is? Does 1 mean new? Does 1 mean old? We don't know. Those are magic numbers. They have no meaning. They just magically make something happen. Therefore, in database, magic numbers are essentially foreign keys. They're great to keep the data down to a controlled set of values, but sometimes you don't know what the ID would be, so you'd use it as part of your field selection criteria like this. So select ID from countries where name is equal to Canada. We all know by now Canada's 5. And ThinkCube anyways. And I fed in the value of Dan because I just created a string for shits and giggles just so I'd have something else up on the screen. Dan's from Canada. Hot damn. This is how you use this as part of the field selection criteria. The rule is if it's used as part of the select statement, it can only return one value. And only one value. That's use number 2. Not so useful. It's usually used when you're creating new records. Or you're importing data from a data source of some sort. So that you don't have to worry about mapping specific values. As long as you know the country list is valid and they're using the same abbreviations as you. At least you can make it match your data without having to reload somewhere else. All right, I just need a second. Well, it's not so useful because it's very specific purpose. It's designed to basically initially set value of one column to specific value, which, depending how you wrote your application, you'll never need to do that. But if you're migrating data, is where you'd use it. So you have a bunch of data that you're bringing in, and you don't know what the matching criteria would be in your database. So you have a bunch of countries, and the data is coming from another customer management system. And you know that they're using full country names like Canada, United States, blah, blah, blah. And you don't want to sit there and take the time to try to map the values as part of the transformation. You could use this method to carry across the values. That's also a subquery. And the next one I'm going to show you is also a subquery, but it's a subquery. That one that has a special name. And this is actually the most useful one of the 3. Because the first one I showed you, 90% of the time you can do with a join. And usually the joins are actually faster than a subquery. This one is useful when you're dealing with aggregates. So remember last week I talked about how you can't aggregate an aggregate? I'm going to show you how to do it now. Holy crap, the hell fell in my eye? Frig if I know. Whatever it is, it burns. I'm right under a vent, so there's probably water up there. That's probably not cool. Rust water. Okay. So what I'm going to do first is I'm going to go and okay, so this might look familiar to people that are working on Lab 8. Haha, Dan's not paying attention. There. All right, so this is something most of you have probably seen by now. Shouldn't be a total mystery. However, remember you can't aggregate an aggregate. So let's say I want to know the average number of order lines per order. And what you do for that is you have to use a special kind of subquery. It's known as a derived table. And I will try to explain as best I can on the first pass. This one's a little gross to explain. What you do is you create something called the derived table. It's a subquery. But what's special about it is it's part of the from clause. So as you can see, I've got my from clause right here. And the query is actually inside the from clause. So if when I run this, it's going to look exactly the same except it took twice as long. Now some of you are wondering, well, why would you bother to do that? It's because if you want to aggregate an aggregate, it's the only way to do it. what's happening is it will take the results of this query, create a table in memory temporarily. So it takes the query, runs it, takes the results of that, creates a table in memory based on your alias right here. If you don't have this alias, it's not going to run. So it creates a table called, in this case, D-table, up in memory temporarily. So it creates a temporary table in memory, gives it some, and puts in the results of that query inside of it. After that, for the rest of this query, it behaves just like another table. You can do joins. You can do all kinds of things. But one of the cool things you can do with it is finally aggregate your aggregates. So let's say we want to know what the average number of lines per order. You could actually do it at this point. However, I always warn, if you're going to do an aggregate inside of this, give it an alias. Because as you can see, it comes out as count. And as far as the table outside here is concerned, whatever these columns are called here is what this table looks like in memory. So I'm going to call this like such. So I'm going to rerun this so you can see that it renamed this column. And it actually will behave just like a regular column. It's not a mystery, it's not magic, it just creates a table in memory. It's a bit like if you're going off to your friend's house and they don't have room for you, then you pitch a tent out in the yard. Then you put yourself inside the tent. This is essentially what just happened, is it created a tent, threw all the data inside the tent, and everybody's happy. And then the party's over and the tent goes away, you included. So now we can actually run an aggregates on this. So I can go average line count. And now this will give me my average number of line count, average number of lines per order. Not the average number of lines total, the average number of lines per order. So I took all the line counts and divided it by the total number of rows. Now, what throws people for a loop a little bit is this one right here. You see, this is line count. Everybody's going, well, yeah, but you did a count of ID. Why is it called line count? Because I renamed it to line count. Whatever is on the outside of the derived table reflects the column names inside the that query. So as you rename your stuff in here, that's what it becomes on the outside. As far as the database server is concerned, this is a real table. Now, here are some of the caveats that come with this. Number one, it's not indexed. It doesn't go fast. It's slow. It's really handy for doing stats and arithmetic and aggregates on aggregates. So you want to know the average number. You want to know the minimum, the maximum. You want to reduce certain other pieces of information. You can do it with this. That's what a derived table is for. You also sometimes use a derived table for really complex queries where you're pulling data and it doesn't really match anything else. Therefore, you do a complex query in the middle that cleans it up, and then you can do whatever math you need on it on the outside. Sometimes you actually do it to make things simpler. However, you have to take into account that any subquery such as this has big impacts because it needs to run the query and then it runs a query again. So for every subquery, so you can figure it's n plus 1. The 1 is the existing query, n is the number of subqueries. So you got to run n plus 1 subqueries. In this case, I'm running 2 queries. And if I do the explain, no, not that, this. As you can see, it does the pull from order lines, does the aggregate and passes it out to another aggregate. So you can see aggregate, aggregate. It does math. If you threw in a join, it would actually do some other stuff in this. And for example, if I want to get fancy, I could throw in and that's not going to work. Yeah. It helps if I include something that has an order date, doesn't it? Query's getting longer and longer as I go. Group by clause. Okay. I'm going to post this and you guys can try to dissect what it's doing on your own. But essentially what I'm doing is I'm saying, okay, I want to know what the average number of order lines per day. Not that it's a particularly useful stat, but in theory you could actually see which days of the month have people buy, or what day of the year people buy the most stuff. You know, January 11th, that was a busy day. As you can see, mostly it's 2. Oh, then I got another one. November 23rd, oh, somebody got ready for Christmas. Yeah, or let's pick up the candy from Halloween. Post-Halloween candy discounts, right? So this is an example of what you can do with a derived table subquery. For example, if I run this query, it gives me my bins by order and then by date. I could actually flip it around and give you date by order, but those are essentially the same thing because each order only has one date, so it's going to be the same size of bin. And it gives you your totals based on each of these. And then it takes it and operates on it on the outside. So that's a derived table. It runs on the inside first, and then it pretends to be a table, and then it operates on the outside. Was that sort of clear? Clear as like lightly colored mud? You got to play with it before it makes sense. You got to play with it. And you will have to play with it before it makes sense. There are lots of tutorials online. There's a bunch of tutorials listed on Blackboard under course documents that you can go through also that also show alternative wordings for these things. No, I'm not playing a game. I'm actually checking. I have a list of things I want to talk about. So, no, I didn't check my putt, dude. I do that during lab. Okay. All right. Did I cover set operations last week? The fact that I got 4 people that know that pay attention or give me the blank look tells me no, I didn't. Problem is that my 2 groups are in slightly different sync, right? So I'm sort of forgetting what I covered with each group. But as of today, you guys will actually be on the same page, which is great. Okay. The next one is set operations. And what a set operation is, do you guys remember doing matrices in math? Now I'm talking like high school. I explained this to my daughter who's in grade 12 and she understood this. And she didn't do so well in grade 11 math and she still got it. So, you know, just putting it, she didn't take grade 12 math. She chose not to. So, set operations. You're operating on sets of data. In other words, you're taking one set of information and a second set of information, and then you operate on them. In other words, you're working with complete sets of information. And you're going to find certain combinations between them. And there's 3 set operators. There's union, intersect, and except. And I'm going to demonstrate all 3 in a moment. However, MySQL does not have intersect or except. It only has union. Why? Because the guys who wrote MySQL decided nobody needed the other 2. Even though except's actually more useful than union. And Oracle does not call it except, they call it minus. And I'll show you guys why it's called minus. All right, here's a big heavy-duty query. Select email from customers. Go. 10,100 rows. Select email from trade show leads. 1,329 rows. So far, I've created 1 set of data, 2 sets of data. Now I want to do stuff comparing the two sets. The first one I'm going to teach you about is union. What does union do? It gives you all the values from set A and set B, but it only gives you the unique values of the two. So that means it'll give you everything from A plus anything in B that is not in A. Sounds like a complicated piece of math, but it's not. Basically, it grabs two piles, finds the unique values between them, and goes. So remember earlier I said it was 10,100, and then I got 1,329. I'm going to hit go, and helps if you don't have a semicolon. I got 10,968.4. Now, if you do the math properly, 1,329 plus 10,100 is not that. However, what it's saying is it found the first 10,100 and it found another 864 in this list that weren't in this list. That's what union does. Hey? Lab. Look in the labs. There's a file called trade show leads, and the instructions in the lab tell you import this file. Lab 8. You need to import trade show leads to do lab 8. Which, if you already did lab 8, you already have this. If you didn't do lab 8, well, you get to watch me do like a third of lab 8 in front of you. Not third, but like the last 3 questions of lab 8. That's a union. So you take everything the results of 1 and then find any new values in set 2. The next one is called intersect. Anybody want to take a guess what intersect does? Yeah. Yes, in both bins. So I got 459 email addresses that exist in both bins. This is handy to find duplicate data. Which, if I turn it around and I go, if I knew how to type, except it'll give you everything from customers except the ones it finds in trade show leads. Now, and I'll run that one too, and you'll see 9,635. Basically, it's 10,100 minus the 459. It's just straight up math. Arithmetic. It's math I can do. Now, those are the three set operators. Now, what would be the use for these? Now, I like to teach using anecdotes. Where I work, we send out mailers on a weekly, bi-weekly basis to our customer base. And we have 2 different bins. Well, technically we have 3, but we have 2 different bins. We have customers and we have leads. Customers are people that gave us money. Leads are people that potentially could give us money. Now, we use a union because every once in a while we'll have somebody that gave us money, say for version 8 of our software, didn't bother buy version 9, and they want to try. They download version 10 to try it, and they have to register their software to run it. That goes into a lead because it's a potential sale. They're already a customer; they're a potential sale, so it's a lead to a sale. If anybody here has ever worked in sales, you know exactly what I'm talking about. Now, when you send out emails in Canada, there's some really interesting laws. They're freaking horrifying. They make the American ones look like Swiss cheese. And the American laws are kind of scary in their own way. But essentially the law says you're not allowed to send the same email to the same customer email address, not the same customer, but the same email address twice for a given campaign. So I sent a campaign today. And if you were in both my customers bin and my leads bin, you'd get 2 emails. Thus, you just broke the law. If you send them out as 2 separate shots, so I send campaign 1 week and I send a reminder campaign the next week, that's okay because it's a different campaign. But you're not allowed to send the same message to the person twice in the same campaign. I don't know what the language is that defines it being the same campaign. I'm guessing there's within 24 hours kind of thing. So you'd use a union because you could grab all the unique values out of customers and add all the new unique values out of You grab all the customers, and then you grab all the unique values out of leads, and you have a clean list without duplicates. Every once in a while, we need to do an intersect, which is we want to send out a campaign to our customers that we know for a fact have given us money at some point, but have downloaded a demo, say, in the last 6 months. That means they're looking at the new versions of our software, and maybe we want to, start hard selling, or we want to refer them to our dealer channel. Therefore, you'd use an intersect to find those that have given us money and have shown interest in our new stuff. That's what you use an intersect for. Accept. And actually, for accept, usually we'd go the other way around. We'd go, give me everything in leads except the ones that are in customers. That means we want to find the fresh leads that have never bought anything from us, so that we can say, oh, you've never bought anything from CADLink before. Let's give you a special promotion. A welcome aboard promo. You get Pantone color palette for free. That'll never happen. That's like $400. But we'll give you this add-on for free that other people have to pay for because you're a new customer. The other guys get a discount for upgrades. Therefore, they're actually getting a bigger discount than you, but you're going to get a freebie that they might have gotten that they don't get for free. Therefore, this is how you manipulate data. And email is the best example because we all understand what email is. We all get those stupid messages all the time in our mailbox. And that's what they're doing, is they're segmenting the list based on unions, intersects, and accepts, and they determine what's going to get sent out to who based on criteria. And there's one last rule that you have to play with. Actually, there's two things you should know about. Union all. Union all is useless. Don't use it. What does union all do? It gives you everything. Duplicates included. Why would you want to use it? I have no idea. But it exists. And I'm sure I could have some database professional come out and tell me this is why you use a union all. And I say, well, couldn't I just use a subquery for that instead? Back to the sledgehammer, right? So, union. The other thing you need to know about set operators is, for example, this will not work. Why does this not work? When you're working with a set, both sides of the operator have to have the same number of columns. You can't compare 2 is not equal to 1. It's like people that have 4 names as opposed to people that have 2 names. You can't do a direct comparison of their names because, I don't know, for one reason their parents decided to give them 4 names. You can't compare because 2 is not, you're comparing 2 data points to 4 data points. It doesn't line up. Which 2 are you comparing? You know? The parser doesn't know. And the other thing you have to be aware of, and I'm just going to throw in a letter here, because the country ID is an integer, and this is a string. We're going to get another error message. Invalid input syntax for integer A. Is A an integer? It's not. That means you have to have the same data types on both sides. So in theory, I could just put in a 1, and that will work. I still get a full set now because I'm adding so much more data to the mix. Therefore, the more columns you add, the more differences you add to the data set. That means the fewer matches there are going to be. Right? So it'd be if I looked at everybody in this room and say, everybody who's got a letter E in their first name, put up your hand. But do it, just for shits and giggles. Anybody who's got an E in their first name, put up your hand. Okay. Anybody who's got an E followed by a C, keep your hand up. There's less of you, right? But how many of you have an E and a C, but not side by side? Right? Because we're playing with different sets of data, we're reducing the amount that match up. Whereas if, say, give everybody who's got an E in their first name, a big bunch of people put their hands up because there's a bunch of people with E's in their first name. The more criteria add to it, the less overlap there is. And I could turn it around and go the other way around. Okay, everybody who doesn't have an E in their first name, put up your hand. Okay. Now, by the same. Keep your hands up. Now, everybody who might have an A in their first name, put your hand up, or has an E in their first name, put your hand up. See, now we're getting more and more names, right? No, what's happening is we're adding more criteria. That means you're getting more rows back. Right? You're adding more criteria, therefore you're adding more data to the set. That means we're finding more variations, thus you're going to get more back. The more variety you add to the column set, that means the fewer things will match. That means you'll get more of it back. Do you see what I mean now? Like the more, it's like saying this is black and white. So how many things are black and white? Okay, now we're going to add gray. How many things are black, white, and gray? Suddenly you're going to get more, even though at one point, if you just went with black and white, the grays would have been included depending on their gamut level. Right? They would have fallen in one of the two bins. But once you start adding one more criteria, instead of having, say, 2 colors, now you got 256 colors because you're adding a gamut range. Because the more data you add to the mix, the more complicated it gets. The more data you get back, and after a while, it's totally useless because you're just pulling back too much. The point of these kinds of operators is to have a reduced set coming back. And unions are really fast. They actually run really quickly. They're actually, realistically, if I go, so that one takes 295. That one takes 44. 295 and 44 is more than 324. By a margin. Yeah, okay. But the unions are quick. Okay. It's part of Lab 8. The instructions in Lab 8 tell you to restore. There's a trade show leads file attached to all the labs. You have to restore that file into trade show leads. I mean into ThinkCube. And then you will have it. It's there. You have to restore it into the database. You download the zip file, extract it, right-click on ThinkCube, restore, point to that file, say go, and it'll actually create the table for you. Like magic. Maybe. Not 100% sure. Actually, I'm 100% sure, but it's, it's a bit magical. Okay. One last topic. And this is one of the topics that's on the course outline that needs to be talked about, but I'm not going into great detail. But I'm going to discuss it really quick. And it's something called views. And every year I use this analogy. And I always say my database prof in college would have kittens if he heard it. For 2 different reasons. One, we didn't have web browsers. They were just coming out. You actually have to remember your URLs for yourself. A view is like a bookmark. Essentially, you create a complex query. So I go, oh, wrong keystroke. Oh, it's not going to finish it for me. All right, so pretend this is a complex query. It's just a straight up, simple little query. It has 3 columns. Now, there's something called a view. Like I said, I treat it almost like a bookmark. What it does is you can write a query and then get the database server to remember it. So you don't have to type it in every time. And by the way, I just use v underscore. You don't have to. You can call it whatever you want. There's no real naming convention on this. I just prefix it with a v so I remember it's a view. And I go run, and I got a syntax error because I forgot the word as. Really? you get to see all the error messages. So I created a view, and what I'm going to do is I'm going to go. So this is the view I just created, and I'm going to hit run. And as you can see, it's the exact same results as this. If I do this. However, this is significantly shorter than that. And that's a view. Now, there's a few things when you got to think about views you got to be careful about. Number one, if you change the number of columns, you have to drop the view and recreate it. You can't just replace it or update the definition. You have to drop it and recreate it. And as a rule of thumb, I tell people, there's a command called create or replace view. I tell people, don't bother do that. It's useless. Because half the time what you're trying to do is you're trying to add columns, you're trying to change a data type, and create a replace view won't let you do that. So you're better off to do a drop space view space whatever it's called, then recreate your view. So you're just basically rebuilding your house over and over and over again. The other thing, as you saw an error message go by earlier, you cannot have duplicate column names inside of a view. This is why I had to give an alias to my state province name. As you can see down here, state province. And the third caveat from views is if you delete one of the underlying tables or one of the underlying columns. For example, let's just say I don't have the column called city on customers anymore. Depending on your database server, it won't tell the view that it's broken. So you'll try to run the view and you'll get an error message saying, oh, I'm missing piece of myself. I don't know who I am anymore. Recreate me. I've lost myself. Because you took away a piece of what it's made out of, but it doesn't know that this is gone. This is really bad. This happens a lot in MySQL. Postgres, depending on the version you're running and what options are set in the control files, it keeps track of the relationship between the views and the tables, so it knows that it's using these pieces. Now, what are some of the uses for a view other than obviously creating a shortcut for a table? It can be used for security purposes. So let's say you're trying to abstract the underlying data, and you don't want the developers or the end users to actually know what the structure of the data underneath is. You'd create a view that amalgamates all these joins and returns a nice clean set of data for them. Another use is for reports. You could create a view that basically is a report. You run it once a month, and you can set it up to export the data automatically. That way you don't have to have these complex SQL statements inside your scripts. You have a select star from this, and poop, data comes out. Views are used to abstract the database, separate the underlying structure from what the end user sees. That's why it's called a view. You're giving the end user a, personalized view of the inside of the database without them having to know what those pieces are. Normally I spend an hour on views. But technically that's all that's required for the course outline is what I just finished talking about. Historically this is all I talked about until last year when we merged the courses and I had to talk about them for an hour. But essentially this is a view. It's what they call a dynamic view. In other words, every time you run it, it pulls the data. It grabs the data from behind the scenes automatically every single time. It's always up to date. That's why it's called dynamic. There's also something known as a I'm drawing a blank. Hold on. It's a static view essentially. And oh, there we go. Materialized. It's not like a word I use in everyday conversation. There's something called a materialized view. What is a materialized view? It is a table. It's actually a table that contains the results of your query. So if I were to do something like this, That's not where that goes. That's a space. Okay, I'm going to create a table called this. I go run. When I go it looks exactly the same as this, except it's empty. Not so useful. The purpose of a materialized view is it's a view that doesn't need to be dynamic. In other words, it summarizes complex data and stores it into a table so that it can be pulled through the day, and then at night, at midnight, it would run a series of batch commands to update the contents of the materialized views. That way, if you have a really complex query that, say, hits 10 different tables and hits millions of rows, those are really expensive. But if there's a summary sitting in a materialized view, you only select star from that table. There's no joins. It retrieves the data instantly without a lot of overhead. And how would you populate this? Like this. Bang, 10,000 rows created. I do this. And now it's back. It's the exact same thing as a view, except this one is static. So if I were to go and delete a customer, which I don't want to do in case I need to help somebody with ThinkCube, but if I were to delete a customer, the dynamic view would reflect that immediately. The materialized view would not reflect it until the next time you refresh it. So that's the two kinds of views. You will not be tested on this topic, just so you know. There is no test on this topic, but I needed to talk about it. And I covered dynamic views and materialized view, how to populate the materialized view, and how would you empty out the materialized view before populating. Anybody want to take a guess? What's the command? One of the few times you ever use it. Gone. 14 milliseconds, all the 10,000 rows of data gone. And as you can see, I truncated that and I didn't get errors about parent-child relationships because the data was self-contained onto itself. This is everything you need to know about views for the most part. There are intricacies, there are details, there are implications. But honestly, if you really want to know about them, that's what Google's for. But this is how you create a view. They have their use. You'll use it for Lab 9 for the bonus points. And now to explain the last bit about Lab 9.